Okay, here we are again. It is example 8-13, and this is coming out of chapter 8, section 3 on the t-test for a mean for mu. Okay. All right, so the subject of this problem is aspirin consumption. So let me read the research scenario. It says medical researchers found that people who take aspirin take on average 8.6 tablets a week. A medical doctor wanted to see if he could reduce the number of aspirin tablets a person consumes if the subjects practiced yoga twice a week. A random sample of 12 people who take aspirin were taught yoga, and after a 12-week period, the doctor found that they took the following number of tablets for 1 week. And they give us 12 data values, one for each of the 12 people in this sample. Test the claim at alpha equals 0.10. Assume the variable is normally distributed. Okay, so in this case here, just go ahead and copy down the data that they give us. So we have, let's get back. We have one subject who took 7 tablets in the week, one took 4, one took 6, one that took 8, one that took 9, another that took 9, one that took 5, and another subject that took 6 tablets, one that took 2, one that took 7, and then one that took 10, and then finally one that took 9. So that's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay, so we got all of the data there. All right. So before we can even get on into the hypothesis test, we need to really quickly analyze the data a little bit. And so won't do this computation all by hand because it's not the point of the exercise. We'll go ahead and take the mean of our sample. So add them all up and divide by the total number. We get 6.83 repeating, and remember the rounding rule is just one extra digit. All right, then also we have our formula. Probably say here to use the shortcut formula for computing standard deviation, which is you square all of the values, add them all up, and then use that formula. But either way you do it, you'll get out 2.3, rounded off 2.37. Okay. All right, so that is basically what we need to get started. Right. Now the step-by-step hypothesis test we'll go through step by step. H subscript 0 is that mu is equal to 8.6. All right, so if there is no effect, so what was the treatment in this case? Practicing yoga. If there is no effect, then we will not reject the null hypothesis, and so we will, say what's the average number of tablets people who take aspirin take, and what's the average number of tablets per week they take if they practice yoga. And we'd say, okay, well, it's 8.6. That's the average in both cases. We couldn't say anything different. Okay, if the research does yield something, the research hypothesis says what? Well, in this case, the doctor is thinking that we might be able to lower the number of tablets they take. So he says this is the average for the population at large. If I don't do the research, if I don't do this treatment, having them do yoga, and here, this is my research hypothesis. This is what I'm hoping the data will show. The next thing we'll do is sketch the critical region. So here it is a left-tailed test, and alpha was given at 0.10. So I have sketched our t distribution, just make a sketch of a bell-shaped curve, right? And then on the left side I've put a little t subscript alpha and put a little equal sign and a minus already, because I know that the value that I'm looking for is on the left. It's to the left of 0. It's going to be a negative. And in the table, I'm only going to see positive values, so that's the workaround, is just take them and make them negative. And then the area there, underneath the curve, underneath the left tail of the graph, is 0.10. Well, the last little thing is important as well. It's the degrees of freedom. So make sure you're looking in the correct row in the table. So going to row 11 and over to, well, just the first column, because that is where one tail and 0.10 converge. That corresponds to one tail alpha equals 0.10. And the value that's in that first column is positive 1.363. And so therefore our critical region begins at negative 1.363 and is every t value beyond that to the left. So it's anything that's less than negative 1.363. All right, so let's just go ahead and flip the page. So then step 3 is going to be to compute the test value. All right, so the formula is basically the same. We don't really have to memorize a brand new formula. We just have to remember the same structure, right? The same structure that we use to compute a z value is the way that we'll compute the t value. So here, excuse me, we're going to be plugging in 6.8 for our calculated sample mean. We have 8.6, that is the hypothesized value of the population mean. Remember, that is essentially the status quo. That is the average for everybody before they started doing yoga, right? We're dividing by 2.37. That was the sample standard deviation that we had to calculate. Okay. And then that is divided by the square root of 12. So we'll work this out, make the calculator do it. We get out negative 2.63. And let's just flip back to our diagram here. We have negative 1.363, and our value was negative 2.63. So we're way over here, negative 2.63. And so notice our t value is well inside the rejection region. So notice this. I mean, technically the rejection region is just this. We're just talking about the t values themselves, but we're drawing the t distribution, this one, and shading the area underneath the curve, that, to just kind of give you the background picture there. All right, so what's our decision? Oh, sorry. Let's flip to the next page. We've seen where that test statistic falls. It falls in the rejection region, so our decision is to reject the null hypothesis. Okay, so we've rejected the null hypothesis, and that means, well, what? That means that the evidence supports the research hypothesis. That basically our research, what we were hoping to prove with this research, actually panned out. There was something to our claim, and it did what we thought. So we can say here, the evidence. Let's try that. Evidence says, well, let's just say the average is lower than 8.6, right? So we're just talking about the evidence, and so we'll just say the evidence says this: the average number of pills that this sample group took, it was lower than 8.6, and that suggests statistically that the population of people who take aspirin and also practice yoga will have a lower average number of tablets that they take per week than just those people who take aspirin and don't do yoga. All right, so that was another t-test for mu, for the mean.